Hello, thank you so much for joining this session, guys. A very good evening to all of you. We are starting with this session in a couple of minutes. Let's wait for others to join. I hope that you have prepared for your other chapters that we have already covered so far. And today, in today's session, we have joined here to learn about circles and areas related to circles. So basically, we are covering two chapters in this live session. So this is going to be one of the most important session in this, 10-day live course. Okay. So I want all of you to bring up your notebook, your pen, be ready to write down your notes and jot down the important points that would be helpful for your examination. Thank you so much for joining this class. I really appreciate your opinions over here. All right, okay, fine. So I believe that we can start now. I can see so many people joined over here with us. So what we can do is let's start with the session. Okay. So as I've mentioned that today we are gonna solve previous year questions from the chapter circle and areas of related to circle. This is day 4 of your series of Be Well with Maths in Class 10 CBSE, right? And in today's session, we are gonna cover this two chapters together. Okay. By the way, let me take this opportunity to help you to tell you that we have started with an exam prep course, which we usually cost is 99 rupees, but this we have a special offer where we are taking only 29 rupees for this course. So do not miss this opportunity. 29 rupees is like a no show amount, right? And you can make sure you can just have you can take the most benefit out of the course and this exam prep series with just 29 rupees. So make sure to visit our website to know more. Well, to give you a quick explanation about who I am, my name is Ahmed Sheikh. I'm a master of science in IT. I have 12 plus years of experience and I've taught over 1.2 lakh students in my experience so far. I am math, coding and robotics subject teacher and I've done my graduation and post graduation from the University of Mumbai. Okay, so without further ado, let's get started. So first of all, the first thing that we're gonna see is that what are the things that we are gonna learn in today's session. Okay, so in today's session we are gonna see about the chapter. So we'll see that what are the things that we have in the chapter and how we can plan stuff. The second thing is that we'll be looking at the important terms that anyone should know before starting with learning this chapter. So basic important key terms that we should know. Okay. Moving to that is the next thing that we have is PYQs. So PYQs are previous year questions where we will be seeing all the different types of questions that have been asked from this chapter. Okay, I hope all of you are ready to be with me, right? So give me a quick thumbs up if you're ready and we all can start with today's session, right? Give me a quick thumbs up, guys. Great, I can see a lot of emojis and thumbs ups coming. I really like this enthusiasm. Thank you so much, guys. Let's move ahead. So as I mentioned, we'll be diving into the first topic of today's agenda. Okay, we'll see what are the things that we should know about this chapter before we get started. First of all, if you see over here, the weightage of this chapter in board examination is 7 plus 5. So 7 marks comes from your circle chapter and 5 marks comes from areas related to circle, right? And if you combine these together, the total score that a person can get from these two chapters is total 12, right? So 12 marks in your hands if you have practiced these two chapters very well. And I must say 12 marks is not a small deal, right? It's a big deal, right? So therefore this chapter becomes one of the most important chapters with respect to your board examination. Moving ahead. Now, what kind of things it contains? So, it contains properties of circle. So, when we say properties of circle, we have intersecting circles, we have internally intersecting circles, we have externally intersecting circles, the relationship between the radius of intersecting circles as well. We have concentric circles, talking about other properties like tangent secant theorem. We also have the property of chord, right? And then we have chord, the distance between the chord theorem, right? All of these things will be covered in properties of circle. Okay, moving ahead to the next thing is we have numericals. So based on the properties that we learn of the circle, right, we get numerical questions around it and we are expected to solve that. There are several theorems which helps us to understand the property of circle even better. To name a few theorems from this chapter, one is tangent secant theorem, the other one is inscribed angle theorem, the third one is gonna be the distance between the center to the chord theorem, right? So these are few common and one of the most important theorems around which the questions are asked in the board examination. Okay, then talking about the next chapter that we have, which is areas related to circle, there the important topics that we should know is area, circumference, arc, sector, segment. All of these things are something that we should know. So if you know all of these things and you can recall that in your mind, then it is clear that these chapters are very clear for you. I hope so things are clear, right? Moving ahead, then in this chapter actually requires a lot of practice, okay? Because until and unless you don't practice, these chapter will always be very difficult for you to understand, okay? Therefore, solving as many questions as possible from these two chapters are really very important, because sometimes remembering all the theorems becomes very difficult. Sometimes mugging up all the theorems also becomes very difficult, right? And therefore it is must that you should practice these questions again and again, because the more you keep on writing the formulas, the theorems again and again in your solution, the more chances that it gets retained in your mind, right? So practice for these two chapters is really very important. Unless the last live session that I have taken for coordinate geometry, that's one of the most easiest chapter in your math textbook, and therefore coordinate geometry doesn't require a lot of practice there, but circles and areas of circle requires a lot of practice. So I believe all of you have understood, right? Great, great, great. Great, Danish. Yeah, I can see the enthusiasm in your chat section. Thank you so much. Right, and I wish you all the best. Fine. So I believe that everyone over here is ready to go ahead and see the PYQs and quickly understand and revise the concepts that we are going to use from this chapter. Right? Give me a quick thumbs up if you all are ready with me. Okay. Moving ahead. Now, few of the basic terms that we have is as follow. We have this diagram and every important points over here are labeled. Okay, however, let's talk about each one of them one by one, because until and unless we don't understand these basic terms, it will become very difficult for us to understand the question and also understand the theorem, and therefore we will not be able to solve the question properly. Okay, so let me explain you each and every term which comes in this chapter that every student should know before starting with this chapter. Okay, the very first thing is center. Okay, so if I point out this black dot over here is the center, and keeping this center we create a circumference around it, right? Okay, so center is a place from where the circle is actually constructed. Okay, then the next thing is radius. So if you join a line or join a segment from the center of the circle to the circumference, then that will be considered as the radius. Okay, moving ahead, the next thing is diameter. So diameter is basically a line which touches the circle in two points, okay, and passes through the center. So that segment actually becomes the diameter. Okay, fine. Moving ahead, the next thing is chord. So chord again is a segment which touches the circle in 2 points, but the only difference between chord and diameter is that a chord doesn't passes through the center. A diameter passes through the center, not the chord. Okay, fine. Basically, if you see, a diameter is also a chord, and that is the biggest or the longest chord in a circle, right? However, we'll call it as diameter because it's a special chord. Why? Because it is passing through the center. However, the chord which doesn't passes through the center will be called as chord itself. So over here, the green portion over here is actually the chord. Moving ahead, the next thing that we have is secant. Now secant is actually a line represented over here by blue color, right? Now the special case about this line is that it can infinitely extend from this side, and it can infinitely extend in this direction also. So it can infinitely extend in both the directions. Okay, now this line intersects the circle in two different points. So if I point out this, so this is one point, we'll call it as point A, and this is point 2, we can call it as point B. So point A and point B are the 2 points from where the secant is passing through, right? And therefore this line will be called as secant. Why? Because it's a line. First point, it is a line. Second, it intersects the circle in two different points. Okay, I believe this is clear to all of you, right? Great, wonderful. Fine. Now moving ahead to the next point is tangent. Now again, the tangent is also a line, but how is it different from secant? Tangent touches the circle or intersects the circle at only one point. Only one point. So this is the major difference between tangent and secant. Tangent touches the circle at only one point. Secant touches the circle in two different points. Okay. Now one interesting fact about tangent is that if you consider the point where the tangent is actually touching the circle, let's name this point as point P, right? And let's name this center as point O. So if I draw a line from O to P, this is basically a radius, right? So the relationship between the radius and the tangent of a circle is that it will always be perpendicular, and therefore you will see in your higher standards that tangent has a lot to do when it comes to physics. Okay, fine. So I believe this is clear to all of you. The difference between secant and tangent is that it touches in 2 points. Okay, secant touches the circle in two different points, and tangent touches the circle in only one point. Okay, I hope so this is clear to all of you, right? Great, wonderful. Okay, then we have a segment. Okay, what do you mean by a segment? And let's park segment for later. Let's talk about sector first. Okay, so let's suppose, and this circle is too much now cluttered, so I'll make a new circle for you. Okay, so let's suppose that I have a circle like this. Okay, and let's say that this is the center, this is a center C. Okay, now what does a sector mean? So if you make a center, if you take center C and then you make two radiuses, let's say this is radius 1 and then the other one is radius 2. Okay, so if you have two radiuses, the area that it covers we basically get an angle, and this angle, the area that this angle actually cover, is actually called as a sector. We call it as a sector. Okay. Moving to the next point is, then what do you mean by a segment? So what we'll do is, I'll make another circle for you to explain. So we have one more circle, okay, and let's say that this is point C, okay, and then we have any two random points on the circumference. So let me use another color. So on the circumference we have point over here and then point over here, okay. So now if I name this as A and B, okay, and if I join these two lines AB, can someone tell me in the chat that what is AB? Is it a radius, diameter, secant, tangent, chord? Can you tell me, guys? Let's see that who responds first in the chat section. Okay, tell me what AB is. Okay, then what I'll do is, after that I will connect AB and AC. Sorry, AC and then BC. Okay. Now, once we do that, what happens is we get this portion. Now, this portion is actually a small portion of the entire sector, and this portion is actually called as the segment. Okay, this will be called as the segment. Great. Okay, so I believe that everyone understood that what all of these things are, right? Then we also have something which is called as arc. Okay, arc is nothing but a piece of the circumference of the circle. Okay, so let's say suppose that I have one circle and its center is C. If I take any random point, let's say this is point A, and then let's suppose this is point B, and let me name this as X and name this as Y. Okay, now if you see that the circumference is actually divided into few pieces. Okay, now what are these pieces that I'm speaking of? So if you see over here, from A to B there is one piece, and guys, tell me in the chat section that is this piece bigger or smaller than the other piece, this one over here, right? So we have one piece which is called as AXB, and then we have another piece which is called as AYB. Tell me which arc or which piece is actually bigger, and it's very clearly visible also over here, right? So we have arc AYB, and then we have arc AXB. Tell me, guys, that which one is bigger. By just looking at it, we can say that AYB is greater, correct? And therefore AYB will be called as a major arc, and AXB will be considered as a minor arc. Okay, so we have two types of arc based on how big the arcs actually are. Okay, so the arc which is small will be called as minor arc, and the arc which is bigger is called as the major arc. Now, why do I need X and Y points over here to express that what arc are we talking about? Because if we do not use that, then that will create some confusion. Let's suppose that we have a circle and this point is A and then this point is B. Okay, and then if I say arc AB, so if I simply say arc AB, then there will be a confusion, and the confusion will be that what portion or which direction should I take this AB from? Should I take A to B this way, or should I take A to B this way? And therefore, whenever we actually name any arc or mention about any arc, then in that case we should always use 3 points. so that it becomes very clear that which piece of the circumference are we speaking of. So therefore, writing one point over here will give us very good clarity that what arc are we talking about, because both the major one and the minor one both are called as arc, right? So if I say arc AXB now, then it's very clear that I am talking about this portion only and not the major one, right? So keep this in mind, and this is something that usually students get confused with, that arc should always be mentioned using 3 points. Okay, I believe this is clear to all of you, right? Now and quickly take a screenshot of this screen, because this will help you to remember the basic terms that you will be using in your upcoming theorems and PYQ questions. Okay, so I believe this is clear to all of you. Now we'll be moving on to the next question. Okay, great, Danish. I see that you are answering correctly. Very nice. Let's move ahead. Okay, now the next thing that we need to find out is this question. Okay, and this is a question that have came in the board examination. Okay, so now the question is, the length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Okay, interesting question over here. Let's try to create a diagram to understand things better. Okay, and I know and I completely understand that clocks comes with different shapes and sizes, but the portion where the time is actually displayed is actually the minute hand always moves in a circular motion, right? Therefore, what we will do is we'll consider that the clock that we are talking about in this question is actually a circular clock. Okay, and let's say that this is the center of this clock. We know that the second hand is the longest hand, correct? So I'll just make the second hand over here. So let's suppose that this is the second hand. Okay, now then the thing is, so let's suppose that this is 12, right? And then we have 1, then we have 2, but we'll not be worried about that. Okay, then what it says that after 5 minutes it moves from one position to another, right? So assuming that its initial position was pointing towards 12, then its final position will be pointing towards 1. So I'll just keep some dotted lines. This will be its final position. So basically the arm to move from 12 to 1. How do I know that it moved from 12 to 1? Because the question says that it has moved 5 minutes, and in 5 minutes a second, right, in 5 minutes the minute hand will move from one digit to another digit. Do you all agree to this, right? Okay, fine. Now I want to find out what the area which is swept by this minute hand. Okay, which means that I want to find out the area which I am shading over here right now. Okay, this is the portion that I am supposed to find out. Now what is the area, what is the formula to find out the area of a sector? Basically this piece over here, this pizza piece, and always remember this, that pizza piece in a circle is called as sector, because when I was in school I used to get very confused between sector and segment. So I used to memorize in this way that pizza piece is actually called as a sector. Okay, so this is sector. Okay, now I want to find out the area of this sector. Okay, now how can I find that? And so the area of sector, the formula for it, area of sector, okay, is equal to, and the formula is theta divided by 360 multiplied by pi r square. Okay, now how do you remember this? If you know guys, this pi r square is nothing but the area of circle, the formula for area of circle. So I'll just write it over here, area of circle. Okay, area of circle. Then what I want is that out of the entire area of this circle, I want to talk about only the theta angle, not the other stuff. And therefore, out of 360, you want the area of only certain angle, right? And that's how you actually remember the formula. Okay, so this is a trick that you will remember, that you should use to remember the formula. Likewise, if I want to find out the length of the arc, so length of the arc is actually nothing but a part of the entire circumference. So how will you remember that also? So what part are you gonna use? So for area, let me change the color. Yeah. So if I say length, and basically this formula is not relevant to this question, but since we are talking about it, let me write it for you. Okay. So length of arc. So length of arc can be found by I'll say circumference. I'll just write over here circumference, and here I'll say theta by 360. So take the circumference, but only of the theta part, not the entire 360. Okay, so that will be giving us theta by 360 into 2 pi r. So this is how you can remember the formula for area of sector and length of arc, and these two things are different. Okay, area of sector is actually the shaded region that I have shaded over here, and length of arc is actually the piece of the circumference, the length of the piece of the circumference that this angle is inscribing. Okay, I believe this is clear to all of you, right? Now the thing is, we'll be moving ahead to the next slide, and I'll just make this diagram once again for our clear understanding. Okay, so here is our clock. I'll say that this was my arm's initial position, this is end position. The angle that it is making between initial and end position is theta. And if you go back to the question, it says that the minute hand is actually 14 centimeter long. So I'll write 14, and by the time the arm reaches here, then also its length will be the same. So 14 and 14 over here in both the sides. What we are supposed to find out is the area. So I'll name this as O, and then I'll say A and B. Okay. So if you see, the formula that we have for area of sector is theta by 360 into area of circle. Correct. Now theta by 360. Do we know the value of theta? No. But we know that it moved from 12 to 1. Correct. So for 5 minutes, basically tell me that how many numbers usually are mentioned in the clock. So we have 1, 2, 3, 4, 5, all the way up to how much? 12. Correct. So we have total 5 sections. Okay, fine. Now what is the total angle? What is the total angle of the circle? So total angle is 360. Total angle or sum of angle will be 360 degree. I want to see that how much degree or how much angle every digit gets. Okay, so I know that there are total 12 numbers, and these 12 numbers are taking are dividing the angle 360 equally. Therefore I'll say angle inscribed by each digit. So the angle inscribed by each digit is equal to how many, what is the total angle that we have? 360 divided by how many digits that we have? 12. Okay, so this will give us 30 degree. Okay, which means that every digit will have 30 degrees. Okay, we can do it this way. All right. The other way that we can do is that in one complete circle, how many minutes we have. So the number of minutes will be 60. You can just divide 60 by 360. You will get the angle for 1 minute. And then because we're talking about 5 minutes, then we'll multiply that value with 5 and again we'll get 30. The approach is different, but you will get the same answer. Okay. So I know now that the value of theta is 30 degree. So I'll say therefore angle theta is equal to 30 degrees. Now because this value is there and I know the value of r also, which is 14 centimeter, I can use the formula to find out the area which is inscribed by this sector. Okay, so what I'll do is I'll use the formula area of sector. Name of the sector will be O. You'll first write the center name and then AB is equal to theta by 360 multiplied by, then we'll write pi r square. So pi r square. We'll substitute the values. So theta is 30 divided by 360 into pi can be taken as 22 by 7 into r square will be 14 into 14. Okay. Now 7 ones are and 7 twos are. These two things will be cancelled. Then 0 0 gets cancelled. 3 ones are, 3 12s are. And 2 division if we do, then we'll get 6 and here 11. Okay. What are we left with? We're left with 1, 11, 2 and 14. So 1 into 11 is 11. 11 into 2 can be 22. So okay, we can further divide this also. So this can be 1 and this can be 3. Can we divide anything else? No. Okay. So we have 1 into 11, 11. 11 into 1 again 11 and then 11 into 14. So I'll just multiply these two numbers. So 11, oh wait, I'll not write it over here. So I'll write it over here. 14 multiplied by 11. It's very simple. It will be 154, but we can still check if we are right or wrong, right? And it's always better to see if we are correct or not. So we have 154, correct? So that will be 154 divided by 3. Okay, and we can divide these two numbers. So here we'll say 154 divided by 3. So we'll have 5s are 15, 1s are 3. We can have 1.03 and this is a non-terminating number. So we'll get 51.33 and even if we round it to 2 digit, this will be the correct answer and we'll get the answer. So therefore we'll say therefore we'll say that area of sector is gonna be of OAB is gonna be 51.33 centimeter squared. Right, I believe that this is clear to all of you. Okay, so this is done. Take a screenshot of this and make sure that you're practicing this too. Okay, moving ahead. Now moving to the next question, guys. Okay, and because we have limited time, so we'll try to finish as much questions as possible. Okay, now here we have in a circle of radius 21 centimeter, an arc subtends an angle of 60 degrees. So we have the length of the radius, we have the subtended angle also. Okay, fine. The length of the arc, we are supposed to find out the length of the arc, and I've already mentioned this formula. So the length of the arc can be given by theta by 360 into 2 pi r. Okay, now because this formula and the previous formula looks very similar, make sure that you're using the correct formula based on what you're supposed to find. Okay, then the next thing is the second thing that we are supposed to find is the area of the sector formed by the arc. Okay, so basically we are supposed to use the second formula also. So area of sector is gonna be what? The same formula once again. Area of sector is gonna be theta upon 360 multiplied by pi r square. Okay, let's move ahead. So just remember the subtended angle is 60 degree and the length of the radius is going to be 21. Okay, great. So moving ahead, we have the value of theta to be 60 degree. Okay, and the value of r to be 21 centimeter. Okay, let's try to find out length of arc. Okay, so length of arc will be theta upon 360 multiplied by 2 pi r. Okay, so that's gonna be 60 divided by 360. Okay, multiplied by 2 into 22 upon 7 into r is 21. So 0 0 gets cancelled, 6 ones are 6 6 are, then 7 ones are 7 3s are. Okay, then we can divide 6 to 3 and this will be 1. Okay, so what do we get over here? 1 ones are 1, 22 into 3, that will give us 66. So 66 divided by 3, right? Oh, 3 can also be cancelled, right? We can skip this point. We can just remove this step. Here what we'll do is I'll cancel this 3 with this 3. That's it. So what we get is 22. 22 what? Centimeter. How do you know that centimeter? Because the unit that we used for the radius was centimeter. So therefore the length of arc will also come in centimeter. Okay, so be mindful about this. The next thing. So first thing that we were supposed to find out was length of arc. So first thing is solved. Now moving to the next part of the question. The next part is area of sector. Okay, and the sector is OAP is equal to again 360 theta by 360 multiplied by, this time we'll use pi r square. Okay, always remember that we'll take the formula of circumference if you want to find out the length. We'll take the formula of area if you want to find out the area of sector. Please don't be confused about this. Okay, great, wonderful. Moving ahead, then what is the value for theta? That is 360. 60 divided by 360 into 22 upon 7 into 21 into 21. Okay, now this is 1s are and this is 6 because we've already done it above. Then we'll see cancellation of this. So 7 1s are, 7 3s are. Now we'll divide 6. So we'll get 6 divided by 2 will be 3, and then this will be 11, and then 3 and 3 gets cancelled. Okay, now what are we left with is we'll say 11 multiplied by 21. That's it. So this is the only thing which is left. So we'll multiply 21 multiplied by 11, which will give you 21, again 21, and that will be 1 3 2 231. So we'll write over here 231, but because we are finding this area, our unit will be always of in square, so that will be 231 centimeter square. Okay, now we'll have only 5 minutes more for our live session to complete, and therefore we'll quickly solve one more question, and that will be the last question of our session. And I'll let you take the screenshot of other questions so that you can practice that. If you have any questions, you can drop that in our comment, and we'll solve in our next session. Okay, moving ahead. Okay, so the next question over here that we have is find the area of the shaded region in figure if the radii of the two concentric circle is given. Okay, so here I believe that the diagram is not accurate, so we'll just get rid of this diagram. Okay, just ignore this, but let me draw the diagram for you. Okay, so what we are going to do is we are going to take a circle. Okay, and we have two concentric circle basically. So I'm going to make one more circle inside this. Okay, now the center is said to be O. Okay, okay, and O. Now the radius is 7 centimeter and 14 centimeter. So from here to here it's going to be 7, and from here to here it's going to be 14. Okay, now the thing is, let's suppose that I've extended this part and I'm supposed to find out, let's say this is A and B. So the angle of AOC is given as 40 degree. We are supposed to find out the area which is over here. Okay, so this is the formula, this is the question that we have. Okay, and I'm really sorry I couldn't add the diagram over here, but this is the diagram that we are supposed to solve. Okay, so 7 is the radius of the smaller circle, 14 is the radius of the bigger circle. Okay, and we are supposed to find out the area of the shaded region. What we'll do is we will actually take the the center as O. We'll take the area of sector of OAB, and then O, let's name this point as P and Q. Okay, P, center O, P and the smaller portion. And when I say remove, it means subtracting. So basically, I'll find out the area of sector OPQ, and then I'll subtract this value from the area of AOAB. Okay, let's see that how it is done. Okay, so the value that we have is R1. R1 is going to be 7 centimeter. Then we have R2. R2 is going to be 14 centimeter, and the angle that we have theta, and theta is equal to how much? It is 40 degrees. So we'll just write 40 over here. Okay, 40 degrees. Okay, now we'll say area of shaded region. Now I'll show you one shortcut, and this is exactly what we are here for, to see that how we can score good in very small amount of time, right? So there is one approach that I have already mentioned, that you're supposed to find out the area of the bigger sector, find out the area of the smaller sector, and subtract the smaller sector from the bigger one. Okay, but this will take a lot of time because you'll multiply the value of pi again and again. Why don't we directly create an equation out of it and then solve the equation only once, right? This will save a lot of time. Okay, so what we'll say, area of the shaded region will be equal to, area of sector A, not, yeah, just a second, it should be OAB, of sector OAB. Okay, sometimes sectors can also be written like this. Okay, however, we can still move ahead with that, minus area of sector OPQ. Okay, now what is the radius of OAB? That is 14 centimeter, and we'll name it as R2, right? So that will be theta by 360 into pi R2 squared. Okay, minus what is the area of sector OPB? That is again theta by 360 into pi R1 squared. And this is how this formula will help you, or this approach will help you to save a lot of time. Okay, because you don't need to solve the same thing again and again. So what are the common terms that you can see over here? The common terms are theta by 360 and pi. And what are the uncommon terms? We have R2 square minus R1 square. So this is the new equation that you got just for the sake of this question. Okay, so now I'll substitute all the values. So what we'll get is 40 divided by 360 into 22 upon 7 bracket R2 square, that is 14 square. minus r1, that is 7 square. Okay, so 0 and 0 gets cancelled. 4 ones are 4 nines are, and then we'll solve it further. Okay, solving it further, we'll get 22, because 1 multiplied by 22 is 22, divided by, we'll write 9 into 7 as it is, and then we'll have 196, because 14 square is 196, minus 49. Okay, so 196 minus 49 will give you what? Let's see. So we have 8, 16, 7, 4, 147. So 22 upon 9 into 7 multiplied by 147. Okay, now let's see if it can be divided by the number. Yes, it can be divided by 7. So let's do this. 147 divided by 7, to 21s are 147. This will be 0, 0, 0. So we'll just write 21. Okay, and 7 will be cancelled. Now we'll divide 21 and 9 by 3. So we have 3 and then we have 7 over here. Okay, this will give you 22 into 7 upon 3. So 22 into 7 will give you 14, and 14 plus 1 is 15. So 154, and 154, let's divide this by 3. So 154 divided by 3 will give you 5s are 15, 1s are 153. You'll get 1. We can put point. Then this will be 3, 3, 3, 3. So the answer is 51.33 centimeter square. And there you go. You got the area of the shaded region. Right? So I believe that you have understood how to use this formula and how to create shortcuts to make sure that you answer the questions really very fast. Right? I believe that all of things, everything is clear so far. There's 2 questions that I want you to solve. The first question that is given for you as homework, or else let's do this. We still have like 2-3 minutes, right? So I'll just help you understand that how to solve this formula. Okay, a tangent PQ at point P of a circle of radius 5 centimeter. So let's say that we have a circle, and let's say that this is the tangent. Tangent means it touches the circle at only one given point, right? So let's say that this is point P, and from here we have a radius, and center is O. The tangent is PQ, so let's name it as PQ this way. So there is one line which joins OQ. So OQ can be joined like this. We know by the tangent property that the angle made by the radius and the tangent will be always 90 degree. So I'll just make it 90 degree, and the value of radius is going to be 5, correct? And OQ is going to be how much? 12. So OQ is 12. This value is supposed to be find out. Basically what you will do is you will use Pythagoras theorem over here. Why? Because we know the value of hypotenuse OQ, we know the value of OP, we are supposed to find out the value of PQ. I give this question as a homework for all of you. Okay, so the equation will be OQ square will be equal to OP square minus PQ square, that is 12 square minus is equal to 5 square minus x square. So x square will be equal to 12 square minus 5 square. You can basically use the a minus b a square minus b square identity to solve it even quickly, and you can tell me the answer. Okay, so this is your homework, you can get it done. Well, that's everything that I have planned for you guys. So tomorrow at 11 o'clock we are gonna have one more live session from Rishabh sir, and he will take you through the entire concepts and formulas of a surface area and volumes. So just make sure that you stay tuned and make sure that you join this live session as well. Thank you so much for joining this class, guys, and I wish you all the best. Keep studying, keep preparing. Do make sure that you like and subscribe our channel so that you don't miss out on any of our live sessions. Thank you so much, guys. Thank you so much.